Hi, my name is Filzah and I am the group leader.
Hi, I am Aina binti Rosli. In this assignment, I was assigned as a problem solver.
Hi, my name is Iman binti Muhammad Sharizan and I am the collaborator of the group.
Hi, my name is Athirah binti Shamsuddin and I am the group assistant.
Roles of each members. First, leader. Work allocation, guide the members' work and meeting, and communication direct, which clear any misunderstanding. The second one is problem solver. Analyze data and question, redefine the problem, and interpret the results. The third one is collaborator. Goal-directed member, able to pitch in between other group members and seek other group to gain information to help members' understanding. And the last one is secretary. Scheduling appointments, organizing and maintaining paper and electronic files, and administrative functions.
We communicate using these three platforms, which are WhatsApp, WebEx meeting apps, and Telegram.
The first meeting was held on 20 January 2021, starting from 8:30 until 9:30 p.m. using WebEx meeting app. All the group members are present. Election. After the discussion, we all agreed to use wheel of name to choose the rule for each of the members. From the wheel, we have Situ Nur Filzah as the leader, Shaza Iman Kistina as collaborator, Aina Zulaika as problem solver, and Nur Athirah as the assistant. The second meeting then was held on 20 January 2021. We use WebEx meeting app and the meeting start at 8:30 p.m. until 9:30 p.m. All the group members are present. First, initiation. Everyone from the group were required to propose their opinion and ideas in solving the assessment. Second, question and ask. To clearly understand the assessment, Aina Zulaika has called our classmate Yasmin Zulaika to ask her about few questions. Discussions. Presenting the answers for each of the questions obtained from each of the group members. Through the discussion, Shaza Iman Kistina found out that her data was slightly different in question 2 and spot an error in finishing the calculation. For question 3, Aina Zulaika and Siti Nurfiza found the similarity and the answers obtained were double confirmed by calculating it twice using Excel and calculator. In order of collecting the right and fit data, the group members choose to use Picker Wheel. Here are the video of the Picker of Wheel app. We use this app to gain the 50 data randomly.
The first question is to present data numerically and graphically. So this is the 50 random data that we pick using Picker Wheel. In this table, the data is grouped by column. First column is DOC followed by SFS and BOD. Next, in table 1, we calculate the mean, mode and median for DOC, BOD and SFS using Excel. Next, we calculate sum of BOD, sum of DOC and sum of SFS using Excel. Then, we also find the sum square of BOD, sum square of DOC and sum square of SFS. Next to it is sum product of BOD with DOC and BOD with SFS. The last table is number of data according to its location for DOC. This is how the data presented graphically. The first graph is sum of BOD and sum of DOC against its location. The second graph is sum of SFS. Second question asks to test at 5% significant level if there is a difference on the OC reading between locations of water sources. Model ANOVA we use is Yij equals to mu I plus Eij for I equals to 1 to 3 and j equals to 1 to 3 until end. The mu I is the ith mean and Eij is the random error which measures the deviation of the j sample from the corresponding treatment mean. Meanwhile, for the assumption, it is assumed that these populations are independent and normally distributed with mean and variances. The null hypothesis can be written as hash note equals to mu1 equals to mu2 equals to mu3 equals to mu4 versus the alternative hypothesis mu I unequals to mu j for at least one of the means is not equal. Then, using Excel, we conduct the ANOVA table. So the first summary table, we can get sum of group 1 until group 4, which represent y1 dot until y4 dot, and we also get average and variances. Next, for the ANOVA table, we find the sum square treatment, sum square error, degree of freedom, k minus 1 we get 3 and n minus k we get 46, and then followed by mean square, f value, p value and f critical. In this case, f value is more than f critical, so we fail to reject hash note. Thus, the conclusion can be made there is no difference on the OC reading between location of water sources at 0.05 significant level.
Next is question 3 Roman. Apply the simple linear regression analysis for the data by checking the model assumption. First assumption is the errors are normally distributed. Second, the mean of the random errors is 0 and unknown variance. The last one is the errors are uncorrelated. Since the random errors are independent, so the value associated with one y value has no effect on the value taken on by random error for other y values. Next is second Roman, fitting a linear regression model that related with BOD and SFS. In this question, we need to find summation of xi, xi square, yi square and summation of xi times yi. After we calculated the summation above, we got 16922 for submission of xi, 57434 for submission xi square, 76.63 for submission of yi, 119.2717 for submission y square, and 25939.72 for submission of xi times yi. From the submissions above, we can find sxx, xxy, and syy using the formula given, which helps in finding alpha and beta. Using sxy and sxx that we got before, we can find beta, which is 3.3098 times 10 to the power of negative 4. Then use beta to find alpha and we get 1.4206 for alpha. When we get alpha and beta, we can form a linear regression model, which is y hat equals to alpha plus beta x.
Next is 3 Roman, testing the linearity between the BOD and SFS at 1% significance level. We started this question by making assumption. H0 give beta is equal to 0, while H alternative give beta is not equal to 0. Reject H0 if t-test statistics is bigger than t alpha over 2 and minus 2. T-test that we got 2.4882 times 10 to the power of negative 6. We can see additional value, which is significance f, at the last column of ANOVA table. The significance f value can be compared to a chosen alpha value. Since significance f is bigger than alpha, so we fail to reject H0. There is no evidence that indicates there is no linear relationship between BOD and SFS.
4 Roman, compute the value of person product moment correlation coefficient for the fitted linear model and comment on the value. Correlation measures the strength and direction of a linear relationship between two variables. To find correlation coefficient R, we use SSX over square root of SSX times SYY. Value of R has no scale and must be in range between -1 and 1 regardless of units. If R is close to 1, then it shows that there is a strong positive linear relationship between X and Y. If the value of R is close to -1, this implies that there is a strong negative linear relationship between X and Y. And as for this question, the values of R is 0.03, which is close to 0. So it shows that there is little or no linear relationship between X and Y. We can see it from the figure shown. Question 4 asks to perform a goodness of fit test to comment if the assumption given is true. H-note gives that BOD readings have normal distribution with mean 1.5 and variance 0.135, while H alternative gives BOD readings do not have normal distribution with mean 1.5 and variance 0.135. The table consists of BOD range, observed frequency, PI value, and expected frequency is shown here. To get the PI value, we have to transform X to Z using the formula Z equals to X minus mu over sigma. Mu is mean and sigma is standard deviation. By putting the value of X, mean which is 1.5 and standard deviation which is 0.135 in the formula, we can get the value of PI for each range of BOD. Since the data of expected frequency for each range is less than 5, we can add the value and we will build a new table data for OI, PI, and EI. Then, X-squared test is performed. The X-squared test formula is the total of OI minus EI squared over EI. The value that we get from calculation of X-squared test is 10.8188. Since K is 4 and alpha is 0.05, we have to find the X squared 0.05, K minus 1 which is 3, then we get 7.8147. Reject hash note if X squared test is larger than X 0.053. Since X squared test is 10.8188, which is larger than X squared 0.053, which is 7.8147. So we reject hash note. There is no evidence that BOD readings have normal distribution with mean 1.5 and variance 0.135. So the assumption is false.